everyone, this is Vikram and welcome to my channel. In this video, we'll see how to containerize microservices written in Golang. We are going to see how to create a Go-based web application and then containerize this application using Docker multistage builds, and then we'll move on to deploying this application inside Kubernetes using Helm. So this is not a complete Go tutorial, but we will cover just enough to understand Golang in depth. So we are going to cover some of the important concepts inside Golang like Go modules and packages, and then some of the basic concepts which are necessary to build web applications. So this is the complete demo for this video. So we are going to start with installing Go language in our Windows-based system, and then we'll also see how to install Go-based VS Code extensions, and then we'll move on to learning some of the important basic concepts which are usually very difficult to understand for the beginners. So the important concepts are Go modules and packages. We'll see what are modules and how to pull the modules from the repositories, how to create our own module and then write packages into it. We'll also see some of the important environment variables inside Golang that are GOPATH, GOBIN and GOROOT. We'll also see what are go.mod and go.sum files and why these are very important when you're building Golang based web applications. We'll also see what are local and remote packages and how to create one. We'll also see what are variables and concepts, and then we'll go to functions and see different types of functions and their return types. We'll also see maps, which are kind of Python dictionaries. We'll also see how to write different packages inside our module. We'll also see what is cross compilation, how to compile your Go source code for various operating systems and their architectures by being in one of the architecture. That means I can prepare my Go application inside the Windows system, but I can cross compile it to Linux based operating system. Then we'll move on to creating Go based web applications using a package known as Gorilla Mux HTTP module, and then we'll see how to create various endpoints like health endpoint and the details endpoint. So these are the custom endpoints that we are going to create in this video, and then we'll see how to write Docker file for this Go application using multistage builds. We'll also see what will happen if you don't use multistage builds and how much image size we can reduce by opting for multistage builds. Then we'll move on to writing the Docker compose file for the complete application, followed by writing the Kubernetes Manifest files like the deployment and service object. And finally, we'll also create the Helm chart to deploy our Go-based application. So these are the prerequisites for this video. We are going to start with installing Golang and then properly configuring it. So when we talk about properly configuring it, I mean to configuring GOPATH, GOBIN and GOROOT directories. We'll also need Docker and Docker Compose CLIs and a Kubernetes cluster like a Minikube cluster. We'd also need kubectl and Helm CLIs to talk to the Kubernetes API server. And at last, we need VS Code for coding. So I highly suggest using the VS Code because of the various features it offers, like code automatic auto completion and finding out the errors, etc. But you can also use Notepad or Notepad++ for this demo. So what is Golang? So Golang, also known as Go, it is an open source programming language which is developed by Google, and it is statically typed programming language. That means that you need to declare the type of variable before you actually use them. So when you compare interpreter based languages like Python, we don't have to declare the variable type because it is automatically calculated during the runtime. But in case of Go, Go is statically typed. That means that you need to declare the type of variable even before using it. And Go is compiled rather than interpreted. That means that so we need to compile the source code into a target machine's binary code. That means if you are running the Go code in the Linux machines, so it is compiled to the binary, so that can be executed in that Linux machine. So it is different from interpreter based languages where compilation will not happen, but the program instructions are executed inside a virtual machine rather than the target machine. So this is the difference between compiled language and the interpreter based languages, and Go is a compiled one. And also compiled languages generally prevent errors during the compilation stage itself, but in case of interpreter based languages, these errors will be detected at the runtime. So being a compiled based languages, Go being a compiled based language, So Go being a compiled based language, it is more powerful, faster, and offer better performance when compared to interpreter based languages. And also Go supports concurrent programming, that is, it allows you to run multiple processes simultaneously. So this is achieved by using Go channels and Go routines. And also Go has automatic garbage collection, so which does the perfect memory management. That means that if you are not using any sort of variables, or if you are not using the imported modules, Go will throw an error and it will automatically remove it from the source code whenever you are using editors like VS Code, so which we are going to see in the demo. And some of the popular DevOps tools like Docker, Kubernetes, Terraform are all built in Golang. And Go is developed based on C's syntax and also with the simplicity of Python. So that means it will have the best of both the worlds, being a compiled language like C and also easy to remember syntax like Python. So this combination makes Go one of the most effective programming languages for developing large scale applications, and it makes easier for debugging complex projects. So let us see how to install Go. So I'm in my browser, so I'll go to the Go's official website, which is go.dev, and then you can directly click on this download button to download the Go software. So automatically the operating system will be detected. So in your case, depending upon the operating system, you will have to download the necessary package. Since I am on Windows, I'll be downloading this MSI package. And in my case, I've already downloaded it and I've kept it in my downloads folder. So once downloaded, you have to double click on this MSI package to install it. So now Go is installed, so we have to click on finish. Now open up any terminal to see whether Go is installed properly or not. So you can do Go space version to see the version of the Go install. So in our case it is Go 1.17 and the architecture is Windows AMD 64. So now once Go is installed, we need to set a various paths. So we'll understand these three different environment variables. So by default, Go root defines the Go installation path. That means it will automatically detect the Go installation path and then it will set this environment variable. And GOPATH directory contains all your Go source code. It will automatically populate with the values like $home/go, that means that user's home directory, and /go, that is the default Go path in case of Unix, but in case of Windows it will be your user profile /go. So this Go path indicates the necessary workspace needed for developing Go applications. In our case, what we'll do is we'll create a folder and then we'll update the Go path to point to that particular directory path. And in case of Windows, you have to set the Go path in the environment variables. In case of Unix, you can just use export and export a new Go path. So Go path directory usually should have three directories, so which are src, package, and bin. Remember, Go path is the directory where we'll be developing and putting all our Go related projects, and inside it we'll have three directories: src, package, and bin. Src is used for putting all your source files. Package is for compiled files, that means that whatever the external dependencies that you wanted to use inside your source code, all these compiled files with .a extension will be put under pkg. And bin file is used for all the executables. That means that whenever you compile your source code, you will have the final artifact. So that artifact, either you can put it in the same directory or you can move it to bin. So we'll see how to move that final exe file or the final compiled file into the bin directory when we are doing the demos. And finally, GOBIN, as the name itself indicates, it is the bin. So GOBIN points to the binary locations of your Go compiled files. That means it will basically put all your final executables in this path. So it defaults to Go path and /bin. That means that the bin folder inside your Go path. So you can also put it according to your own path requirements. Now let us open the terminal and see all these environment variables. I'm going to open a terminal known as tabby. So you can also use the command prompt, so it is entirely up to your choice. So I like the tabby terminal, so I'll be using it. So basically I'll be running some go commands. So the first one is the go help to print the help menu. So these are the various commands supported by your go CLI, and we will run go root to print the, so go root is not set, so by default it will point to the installation directory. So let us see the go path location. So this is the path where it will create a folder known as go inside my users home directory. So let us also see if go binary is set or not using echo GOBIN. So even this is also not set, so we are going to set all these paths accordingly. And now we want to see all the environment variables. So all we have to do is type go space env. So this is going to show us what are the various paths available for your go environment. So as you see, go path is set here to the go directory inside the users home directory, and also go root, it is C drive program files go, this is the installation path, and there are a lot of other paths as well. So now what we'll do is we'll try to create a directory, and then we'll update GOPATH and GOBIN accordingly. So now these are the various commands supported by your go. So the go help will display all the help commands, go version will display the current version, go env will display all the environment variables that are used for go, and then go mod init module name. So this will just create a module which we are going to see in the demo section. And then if you want to download a third-party package from source code repositories or from anywhere, we can use go get and the name of that module, and then go run file name. So this will run your go application, and go build, this will compile your source code into the executable, and it will put the executable in the same directory of your source code. And at the same time you can also build the source code, compile the source code into an executable with a different file name. So all you have to do is you have to use -o and give a file name, so that will save the executable with a different file name. And go install, what this will generally do is it will compile your source code and generate the final executable, but the thing is it is going to copy or move that the final executable into go bin directory, which is usually gopath/bin. So instead of putting in the same directory, it is going to move to this directory. So now let us try to understand what are modules and packages. So before this, we are going to create a folder where we are going to put all our go related projects, which we call it as go workspace. So in my D drive, I am going to create a folder here known as go projects. So this is going to be my go workspace. So first what I'll do is I'll take this directory, and before updating the go path, as we already know that we need to have 3 different directories inside our workspace. So the first directory will be your src directory, and the next one will be your package. So this will put all your compiled external dependencies, and the third one would be your bin, where your binaries or the final executable will be copied into. So I'm going to take this location. Then what I'll do is I'll open the environment variables, and then I'm going to update those environment variables. Just click on this environment variables section. So by default go path is already set, which is the default one. So inside the system variables, I wanted to create one more path, so which will just replace the go path. So the go path, which is the workspace for your new go projects, I'm going to set it like this, and I will add one more variable known as GOBIN, so which is the binary location of your go projects. So it is /bin inside your go path. So this first part is your go path. Inside it we will be having a GOBIN directory. So I'm going to click enter and set the environment variables. So now open up a new terminal session, and now let us see what are the variables of go path. And so all you have to do is you have to just use go env. So this will also show you all the environment variables. Now if you see the go path. So the go path is here. So I think this is not updated properly. Let us close this terminal session and then try to open a new terminal so that will reflect the changes that we have done. Now I'm going to type go env. So now if you see, the GOBIN directory is now, it is under C drive go projects bin. At the same time, GOPATH is also modified. So GOPATH is not modified properly here. So what we'll do is we'll also change it in the user environment variables, or else if you remove this, it is going to take the system's GOPATH, since this is already there. So what I'll do is I'll just remove this. And now if I just choose go env again, and let us close this terminal session and open a new one. If it is still not detecting, we are going to enter it into the user as well. So what I'll do is I'll just use go env, and this time if you see, it is properly set. So all you have to do is you have to remove the user defined go path. So now it is in the C drive go project. So I'm going to close this and I'm going to use VS Code to open this go project. So all I have to do is I have to open this go project, which is currently my Go workspace. So as we mentioned, so the Go workspace will have bin, src and package directories. So now first thing which I wanted to do is I wanted to create a module so that any other other developers can also use my module by cloning it. So before doing that, let us try to understand what are Go modules and Go packages. So Go code is grouped into packages and packages are grouped into modules. That means that we have modules in the higher level, and inside the modules, so if this is a module, we have the various packages. So each package will have the .go files. So that means that a module is composed of packages and packages are composed of Go files. A package is a directory with Go files that organize the code into reusable units. That means that we can reuse the packages. And at the same time, a module is a collection of Go packages with dependencies and other versioning built in. So we are going to understand what is this dependency and what is this versioning. So programs start running in a package known as main. So inside your package, so your main program starts with a package known as main. So that is where your program execution usually start with. And inside this package main, we'll be having a function known as main. So in the demo also, we are going to see it very clearly. And all the packages that your Go source code needs are put inside the go.mod file. So this go.mod file usually lists out all the dependent modules that your Go project usually needs. So this Go project, let's say that you need external modules developed by other developers. So all you have to do is we have to update this go.mod file, so which usually lists out all the external dependencies. And the basic go.mod file is the repo. Basically all these modules are checked into the source code repositories like GitHub. So if you open the go.mod file, you're obviously going to see all the GitHub repositories that contains the external modules of Go. So now when we talked about the Go packages, we are saying that the program execution starts from the package known as main. So let's say that I have a file known as hello.go, and this is inside a package known as main. So that means that your program execution start from this very file, so package main, and we'll also have function main. So this is the starting point your complete Go application. Now let us try to understand the difference between two important files, go.mod and go.sum. So whenever you initialize a module or create a new module, so these are the various files, or these are the very important files that we are going to see inside any Go project. So the first one is the go.mod and the next one is the go.sum. Usually these two reside at the root of your project. Let's say that I have created a project known as Go Microservices inside the source directory of my Go workspace. So whenever we create it, we are going to create two more files known as go.mod and go.sum. So go.sum will be automatically generated. So this is the file that we wanted to create. So these two files are responsible for precise versioning of the dependency without breaking it. That means that if anyone has access to our source code, they can see the go.mod file to see exactly what are the dependencies that my Go project is dependent on. And all these dependencies, whatever the dependencies that are mentioned in go.mod file, will be automatically downloaded into the package directory, and inside this package directory there will be one more directory which is automatically created, which is a mod. So all the project dependencies will be mentioned inside the go.mod file, and if you download those external dependencies, they go and get placed inside this pkg directory. Now if you open, or if you wanted to create a module for yourself, let's say that I wanted to share this module inside the GitHub so that other developers can use it. So instead of creating plain project, what I'll do is I'll create it as a module. So in order to create it as a module, we need to create the basic structure. It is like creating a Git project using Git init. So we have go mod init and the name of the module. So usually the name of the module will be linked to your GitHub repository. So once you do go mod init and the path to your module, so it is going to automatically create this go.mod file, so with the name of your module and the version which you have used to create this module. So that is the first requirement. And let's say that when you're writing the source code, or when you're trying to develop your the Go application, so you might need a lot of external dependencies. Let's say when you're writing a Go file known as hello.go, so there is a requirement of using a third-party package which is rsc.io/code. So this is the package which you have used, but still it is not known to your system. So in order to download this, there are two ways. Either you can use go get and then the name of the module. So this will download all the dependencies and they will be put under the pkg directory. But there is one more other way which is called go mod tidy. So this will see all the external dependencies that you have used in your Go program, and then first what it will do is it will download all these external dependencies, and then it will also update your go.mod file. So as we mentioned earlier, go.mod file is the main file that tracks your dependencies of your Go project. So this go.mod file should also have these sections, so which usually define the requirements for your project. So this is one requirement. So that requirement will be added or updated in the go.mod file. So the go.mod file is pretty much clear to us. It will track the dependencies. But what about the go.sum file? So go.sum file usually contains the cryptographic checksums of the each module. Let's say that you have used code module. The code module might depend on some other modules. So this go.sum will calculate the cryptographic checksum and it will be updating inside the go.sum. So we'll try to understand why these checksums are needed. So every time when a dependency used inside your Go source file or the project which you are trying to do, so what generally Go will do is Go will download these dependencies, then it will create a checksum and it will update that checksum in the go.sum file. So the reason why this is needed is next time when the Go module has to be compiled, so already when we download the external package, so they will be moved into pkg directory as the pre-compiled packages, and at the same time checksums are also calculated. So those checksums are compared with the checksums with the go.sum. So if there is a mismatch in the checksum, and again the modules are compiled again, but if checksums are matching, so we don't have to rebuild those modules. So it will help us in building our Go projects faster by comparing the checksums. So now let us try to create our own first module, and let us try to learn some basics, and then we'll move on to creating the web applications. So I'll go to the VS Code So inside this VS Code, first what I'll do is I'll create a directory known as go microservices. So this is the name of the module which I'm going to create. So this is the go microservices. So inside this go microservices, so what I'll do is I'll go into this directory. So I'm going to select the bash as my terminal because it is easier for me. So I'm going to go inside the src directory and then inside the go microservices. So this is the first the go module which I'm trying to create. But as mentioned earlier, go we'll call it as a module once we have the go.mod file. So the first thing that we have to do is we have to first initialize this go module by using go init, and then sorry, it is go mod init, and then name of the the name of the module that you wanted to create. So before creating this module, I wanted to also create a GitHub repository. So I'm in my GitHub repository. I'll create a new repository. The repository name, I wanted to keep it as same thing, which is go microservices. So I'll be just creating this plain file, plain GitHub repository, and then I'll create it. So what I'll do is I'll take the link to this repository so that I can use this as a name of my new module. So remember, modules are always checked into the source code repositories. So go mod init, and now I have created this. So automatically it is creating a new go.mod file, and once you open this go.mod file, you can see that the name of the module is this. But if you see, I am getting a lot of errors. This is due to the fact that I don't have go extension. So I'll go to the extension section and then I'll search for go, and then I'll install this extension. So once extension is installed, so automatically go modules are automatically detected. So this is the creation of the empty module. So we haven't done anything, we have just created a module. So now let us see and also understand for the fact here that go.sum file will only be created whenever we are using or importing any third-party modules. So first thing which I'll do is I'm going to create a new file known as main.go. So I'm going to start writing my source files from here. So it is asking me to install some other things, so you can just click on install all. So it will install all the dependencies for your VS Code. So now first thing I'll do is I'll try to learn about some Go basics, and before that I'll also try to explore the Go documentation by going into its official website. So I can just click on this get started section over here. So in order to understand the various features of Go. So after download, what I can do is I can go through this documentation. If you wanted to go step-by-step tutorials or interactive tutorials, you can just click on this take a tour section. And also if you want to run Go inside the web terminal, so you can click on this go to playground, where you can run your Go source file directly in the browser. So I'm going to click on this documentation section over here, and the first instruction is to download and install, which we have done, and then click on this getting started tutorial. So this is going to give you the basic tutorial needed to get started with your Go programming. But before doing that, let us try to understand some of the concepts inside Go. So this is the first basic example of Go. So we already done with the installing the prerequisites like the installing Go and setting up the path, and then we created a new directory, and also we initialized it to be a GitHub module. So if you see the go mod init command that they have used here, it is for the local dependencies. But since I wanted to create a module that I can check in into the Git, so that's why I used my GitHub repository URL. And the first source code that we should try is this hello.go file. So I'm going to just copy this and then I'm going to paste it in a new file called main.go. So we'll try to understand exactly what is written. So as I said, every program will start with the main package. That means that these source files belong to a package known as main. Okay, so package main, that means that this go file belongs to that go package, and import is the key that we are going to import external packages. Here fmt is a package known as formatting package. So this is similar to standard input stdio.h in case of C language. So here using fmt package we can use print statements like, so every function package main will have a function main. So this is the starting point, so that's why we'll have this function main. And what is this function main doing? So it, whenever it is invoked, so it is going to just use a println function to print the string which is available inside the parenthesis. But how to run this? So there are three ways of running this particular source file. So the first one is the go run command, go run, and the name of the file which is main.go. So this is not going to generate your final artifact like the final exe file or depending upon the OS variation. So this is just going to run your source file. So go run main.go, simply it will compile and it will show you the result. So what if I wanted to generate the final artifact or final generate the final executable? So there are two commands. The one is the so the one is the go build command and the other one is the go install command. So as I said, whenever you use go build and the name of the file which is main.go, so this is going to generate your final executable in the same directory. So if you see on the left hand side, we have the main.exe, and remember we are running the go inside the Windows platform. That is why the final executable is in the executable which is understood by the Windows. So in order to run it, so all you have to do is you have to run ./main.exe. so this will just execute your final executable. It is going to print hello world. And then in order to remove this exe file, there is one more command. So the command is known as go clean. So this will remove all the executable executables in the current directory. But what about moving that final executable into the bin directory? So as we said, GOBIN is the environment variable that defines the bin directory location. So it is automatically set to the path/bin. As I said, path is nothing but your Go workspace. So now what I'll do is, instead of go build, so I can also use go install command. So it is go install and the name of the file it is main.go. So this is going to generate your executable, but this time it has moved into this bin directory. So this is where you will have the final executable. And at the same time, whenever you're trying to build your application using go build main.go, so you also have an option to change it name from main.exe to a different name. So all you have to do is use -o, and then you can just give the name of the executable that you want it to be. So this will generate the executable with that separate name. So I'll just use go clean to clean the executable once again. So now what I'll do is I'll go to the next example. So it is the data type. So Go supports wide variety of data types. So we have the boolean, which is either true or false, and then we have the numeric data types like integers, signed integers and unsigned integers. So we have int 8, int 16, 32 and 64. We also have the floating point data types like float, 32 and 64, and we have the complex numbers as well. So we have some other special types like byte, rune and string. So byte, it is just an alias for the unsigned integer 8, and rune is nothing but it is an alias for integer 32. And we have the other data type known as string. So before moving forward, let us again go back to the official documentation. And once they have this function created, so we can run it using go run. And now how to call a code in the external package. So this time what we'll do is we'll try to call an external package which is not available with us. So the external package is nothing but the rsc.io slash code. So here they will generate a random code. So how do we do this? So we are going to copy this particular import statement, and then we are going to go to the VS Code, and then I'm going to import the extra dependency. And if you save it, so the one thing that you have to note down here is that, so whenever you imported a package but you have not used it yet, so once you save that file inside the VS Code, so Go is automatically going to remove it. So this is just like an automatic garbage collection where the unused imports or unused variables will be automatically removed. So you can also import, but at the same time you should use it somewhere. So from the official documentation, so what they are doing saying is, if you just call the go method inside this code package, it is going to generate a random code. So I'm going to take this fmt.println, which is a print statement for printing a text. Now we are using this code package. So if you save this file, so it is not going to remove this package automatically. So this is one thing. And if you go to the official documentation, so all you have to do is use go.mod tidy. And the reason why we have to do is, here we have imported a package but it is not available with your local Go installation. So there are two ways. Either you can use go get and name of that package, but we'll do a better way, which is go.mod tidy. So remember, your go.mod file will list down all the dependencies of your Go application, but you're trying to use a library or a package known as code, but it is not updated here. So once you do go.mod tidy, it is going to do two things. One, it is going to download that package. At the same time, it is going to update your go.mod file. So if you see here, go.mod file is automatically updated. So these are the required ones. So the first requirement is code, and these are the extra dependencies. So now someone who is trying to use your Go program or the Go application, so they'll come to know that these are the packages which are needed. So now if you wanted to see where are the packages that are downloaded, so you can go to the pkg directory, and inside mod, so you can see the rsc.io and code package. So this is where your compiled source file is automatically inserted. Now if you go to the main.go file, and then if you try to save it again, so that error is gone. So in order to run this, so we know we have go run or go build or go install, but we'll be using only go run. So go run main.go. So first it is going to print the hello world, and in the next line it is going to print a random code from the code package. So this is the random code. Now let us move forward. So in the next, so we have the data types, and now what are variables and constants. So we already know that variables are the values which keep changing, and constants are the one which remain constant. So Go has a special way of declaring and initializing variables. So if you are coming from the C background, so if it is integer, it is going to int x is equal to 0. If we are coming from the Python background, it is simply x is equal to 0, because Python is dynamically typed programming language, but your Go is statical typed Go programming language. But in case of Go, there is a different way of initializing and declaring your variables. So it is using the var keyword and the name of the variable. Let's say if it is x and the type. So type is integers, and then you're going to initialize it. So type is not mandatory to be initialized. Even you can use var x is equal to 10. So Go is intelligent enough to declare x as integer. So there are other ways as well. So you can also initialize 3 different variables at the same time using var x, y, z equal to 1, 2, 3. And then you can also declare a variable and then initialize later using var, and the name of the variable is w, and the type is float 64, and in the next line I am initializing. So this is how you declare and initialize. You can also initialize a string data types. So var name and the data type is string and the initial value which is hello world. So you also have an option to declare booleans. So var boolean is the data type and the name is working and the default value is true. So for every variables, if you're not declaring or initializing in any value, so they're going to take the default values. And at the same time we have the constant for all the constant operation. So instead of declaring, like instead of putting this var keyword and integer as the data type, so there is a shorthand notation. So the shorthand declaration is, if I wanted to initialize x which is of type integer, so I can use x like this. So that means, so this is a shorthand declaration where we use the excuse me, where we use the where we use the colon equal to. So it is just like using var x int is equal to 0. In the shorthand we are using x colon is equal to 0. So this is the shorthand declaration. So we can also initialize multiple variables like x, y, z, and this is the shorthand notation. So this is needed when you don't want to declare the data type or data type is not known and you wanted to go to in for that for you. So let us go to the terminal and try to learn a bit of examples. So I'm going to declare one or two variables. So all I have to do is variable x of type integer is equal to 10. So this is going to declare declare an initial and integer x. But the problem is, as I said, if you declare as some variable but if you don't use it, Go is going to throw an error. So all you have to do is you have to use fmt.println and you can just print x so that that error is removed. So you can also declare more than one variables like y comma z equal to 2 comma 3, and then as I said, you have to use them somewhere, either in the print statements or for any operations, otherwise Go is going to throw an error. Now I can also declare a string object. So using var name and then it is a type of string. So you can initialize it in a different line using name is equal to DevOps like this. But at the same time you should also be able to print it. So now that error is removed. So instead of doing all these, so it is saying should merge variable declaration the assignment in the next line. Okay, so that is fine. And in order to use the shorthand declaration, so I can remove all this. So if you want, you can also execute one time. So go run main.co, it is going to print 10 2 3 and DevOps 10 2 3 and DevOps. So in order to go for the shorthand declaration, what we can do is, and at the same time here you can also remove integer, so automatically it will be taken as integer. But the problem is you cannot directly remove var because Go will not understand whether it is a constant or a variable. So in order to remove this kind of a dependency, I can use shorthand declaration, which is x colon equal to 10, and at the same time if you wanted to have a string, so name colon is equal to some DevOps. So now you don't have to care about what is the data type of the value. So Go is automatically going to calculate that for you. So now here if you see y and z are unknown, so that is why Go is trying to throw an error. So if you remove them, Go is going to remove those errors as well. Let's say if you wanted to declare a boolean, let's say if the student or if the employee is currently working today or not. So he is working and then colon equal to false. So this is the boolean. So you should also be using this. So this is how you declare even booleans as well. So undeclared name is compiled. Sorry, you have to put quote, otherwise it is going to throw an error. So this is about the variables. So now let us go to the next topic. So FMT package, basically FMT package, it is a format package which is going to print some information onto the console. And also you can also see the variable type and size. Let's say in our program we are using integers, names, the string names, etc. You can also see what is its data type, whether it is an integer, string, and what is the size, how many bytes it is going to take. So we have a package known as unsafe package. Using unsafe package and size of function inside it, you can see what is the what are the number of bytes that your current variable is taking. So what I'll do is I'm going to go to the VS Code. So now I wanted to print the type and size of this variable name. So what I can do is I can use fmt.println, and now so instead of println I can use the format printing. So instead of ln I can use f. So this is going to use formatted printing. So first thing that I wanted to know is the type of name. So the type of name, so I can use %t, that is going to give me the type, and size or the number of bytes it is occupying. So I'm going to use a %t, so that is for the integer. Now in order to replace %t and %t, so I have to supply the actual values. So for %t, what is the type? So I'm going to give it as a name, then name will be printed in the form of the type. And also for printing the size, I have to import the another package known as unsafe. So it is unsafe dot size of name. So in order, if you are using unsafe, simply if you put save, this unsafe package will be automatically added. Okay, so we are adding an extra bracket over here, and now if you see unsafe, automatically it is added. So if you are adding, that is fine, or else if Go detects that you have used a package but it is not imported, it is going to automatically import that for you. So now we are going to run this program using go run main.go. So in the last line it is going to show what is the type of name variable and what is the actual size it is occupying. So the type of the name is a string and the size is 16 bytes. So this is about the size of operator under the unsafe package. Now let us talk about functions a bit. So we all know that functions define a block of code that does a specific task. Let's say if you have repeated a set of tasks to be done, so you can put all of these tasks into a function and you can call this function n number of times. Let's say that you have a requirement of calculating the properties of a rectangle, like the area and the parameter. So instead of using the commands or writing the logic every time, you can put that complete logic inside a function and you can call that function n number of times. So functions are declared using the function key and the name of the function, and what are the parameters that your function expects. And the one more thing that you have to do is you have to also give the return type, whether you are returning an integer from a function, or if you are returning a float from a function or a custom data type. So the return type is mandatory if you are trying to return something. Now let us try to create a function that will just calculate the area and perimeter of a rectangle. So I'm going to go to the VS Code. So I'm going to create one more function. The function name is up to you, but remember, function name should always be started with the small letter if you are not planning to export this function into another package. So in case if you are trying to export it, it should always be capital letters. So I wanted to create a function known as rectangle, or rectangle props, so which is a rectangular properties. And now what are the various inputs it expects? So it expects a length and a width. So once you do length, remember you should also give the type. So the length is of type integer, and again width is also a type of integer. So I can also put width integer, so height is not needed, so I'm going to remove it. So instead of defining int twice, so what I can do is I can remove the first int and still I can use the int at the last, so it is an integer for both these variables. So these are the function inputs, and at the same time I wanted to return both area and the parameter in one go. So that means that there are two return values. So the two return values are of type float 64, and at the same time, so the input, it is also a float 64 because I will never give the integer values. So input is also a length and width also should be provided in the form of an integer, float, and at the same time the return values are also a float. So what I'm going to return, so first what I have to do is I have to create an area. So area, let's say that area will be calculated in the float 64, so it is float, so float 64, but you don't know whether it is float 64 or integer, so you can always use the shorthand declaration so that the data type is automatically calculated. So what is the area? It is obviously length into width, so it is length into width. And now and then the next one which we are going to calculate is the perimeter. So let's say what is the perimeter? It is 2 into length in length plus breadth. So I'm going to use the shorthand notation, so it is nothing but the 2 into length. So in this case it is you have taken it as width, so there should be an addition symbol over here. So this is 2 into length into width, but we are not trying to return them, so we will be returning both area comma perimeter. So that's the reason why, so we have the two return types here, float 64, float 64. Let's say if you wanted to return only perimeter, then you have to remove the extra float 64 over there. So this is about creating a function, but how do you invoke it? So we'll invoke it using the, so it is saying function, this function is unused because we have not used it yet, so I'm going to use it at the end. So we know that the function is returning two values, so area and parameter. So let's say I'm capturing it with a for the area and phi for the perimeter, and then so I don't know what are the values that it is going to return, although I know it is float 64, but I'll use the shorthand notation so that it will be automatically calculated. So now I can use the rectangle properties, and then two values I wanted to pass 1, 2. So 1 will go and replace this with length over here, and 2 is going to replace this particular width over here. And then what I'll do is I'm going to use the fmt dot println to print the area and width. So area is if it is a float, if it is %f, and perimeter is also %f, and I'm going to supply both these values, which is a comma p, and at the same time it is not println, it is formatted printing, it is printf. So now I'm going to save this file and use go run main.go to run it. So both area and perimeters will be calculated now. So the so if you use println, so it would have printed in the next line. So you can also put /n over here, so that the output won't be in the mixed format here. So the area is 2 and the perimeter is 6. And there is one more way to use the functions. So the other way is named return. So in the last demo we had seen that we had written area and perimeter, but we know that these are the two values that we are going to return. So what we'll do is we'll put these names in the return type itself, area and perimeter of float 64. And now we don't have to put area and perimeter here, simply we can put return, so that it will automatically return both these values. So these values are here. Okay, so now what I'll do is I'm going to go to the VS Code. So I know that I'm going to return area and perimeter. I'm going to cut it here, and paste it here, and both area and perimeter of type float 64. So just save this particular file. So it is saying no new variables on the left hand side. And now one more thing, here if you see area and perimeter already defined to be float 64, but if you are newly using this notation, that means that it is declaring and initializing. So but declaration is already done, so that means that this colon can be removed since we already set them as floats. So if you run them again, so we are going to get the same result. Area is 2 and perimeter is 6. Now let us go to the other examples of Go, so which is maps. So basically maps are like Python dictionary type where we'll have a key and an associated value for it. So it is generally used when we wanted to send a JSON like response to someone who is calling our Go REST API. So the reason why we are learning is we are going to use them for sending out the JSON data. So how do you create a map is by using a map key, and the key, what is the type of your key, whether it is an integer key or a string key, and what is the value, whether it is a float or an integer. Okay, so we are going to define it with var, and the name of the map is days of the month, and the maps as the key, and map object, and the string is the key type and the integer is the value type. So once this is declared, you can initialize it with various values. That means that the name of the map, and inside the bracket particular key and the value you wanted to assign. So you can also assign, and we can also create a map and assign values at the same time using var days of the month and using map and the integer over here, and at the same time you can initialize it with key value paste. Here key is the Jan is the key and value is 31, Feb is the key and value is 28. And also you can also use shorthand notation to completely ignore this var key using colon equal to. So what we are going to do now is we are going to open the VS Code and do the same thing, because this is pretty much needed for our demo. So now what I'll do is I'll create a map. So I'll create a map known as days of the month, and then so this is nothing but a map. So the days of month name will be it is obviously string, and the value will be integer because we are calculating the number of days like 31 days, 21 days, etc. And then how to initialize the how to put the values. So the days of the month, and then which day you wanted to which month you wanted to put. Let's say if it is Jan, so the key is Jan and the value that we are going to put it as 31. So this is how you declare and initialize a map object. But you can also do declaration and initialization at the same time by using var days of the month equal to map object. So I'm going to just comment out this one. So the variable days of the month, if you see, we are not putting any variable, so we are letting the Go decide for us. But on the right hand side we are creating a map object. So that means, so the left hand days of the month should also be a map object. So we are going to initialize it like this over here. So that means Jan will be your key, and then quote colon, the value is 31. Let's say we have one more key value pair, Feb. So let's say the days as 28. So this is how you declare and use it. But since we are not using the days of the month variable, so it is going to give us an error. So if you try to print it, even that value will be, so we have to use println because this is not a formatted printing. So this is how you create a map and then you initialize it. So this is one of the important things that we wanted to learn because we are going to use it in the demos. So now this is about maps. So now let us go to the other one. So how about importing a local packages? Let's say a module can have multiple packages and every package will have a lot of Go files. So we have been seeing a lot of imported packages. So if you go back to the VS Code, so we have been using a lot of third party packages like unsafe, fmt and rsc.io.code. So how about creating our own packages? So in order to create a new package inside this go microservices module, I'm going to create a new folder and I'm going to name this as geometry, because this is the package name. And inside this package I'm going to create a new file known as geometry.go file. So this is just a name of the file. But once you start writing the go program, so this particular geometry.go belongs to a geometric package. So we have to name this package as geometry, so which is basically the name of the directory itself. So now I can create various functions or put some variables where my main.go file can refer them or can import from this particular package. So earlier we were importing the functions from the external packages, but now we have created a new package known as geometry.go package, so in which we'll define let's say some functions like you can also create area and diagonal of a rectangle or any sort of functions. So now whenever we declare a function in case of modules packages, so we have to declare it with the capital letter as the first letter, because in the earlier scenario in the same main.go file, so whenever we are using small letter for creating the name of the function, so this function cannot be imported. But since in the geometry.go we are creating a lot of functions and these functions has to be imported into another package, so I'm going to use the capital name, and then I wanted to use area to calculate the area of a rectangle. So let's say rectangle will have the length and then it will have the width, and I'm going to use float 64, and I'm going to return only area, so there will be only one return type, which is float 64. And then what I'm going to return, I'm going to return length into width. So this is about returning area of a rectangle. So now I wanted to define one more which is a diagonal. So basically diagonal will also take the length and width and it will also return the diagonal. But this time what I have to do is I have to return, so what is the area of the diagonal of the rectangle is root L square plus W square, length square plus width square. But in order to have the root, I have to import the math module math package. So I have to use math dot square root of, so it is L square plus width square, so it is length into length and then plus width into width, and then everything should be put inside the brackets. So now this is math dot square root, but if you see, so we haven't imported the math package. So if you just save this file, automatically Go is going to import it. And now I have a package called geometry, in which I have defined two functions, area and diagonal. So if you want to start writing the comments, double slash is for writing the comments inside Go. So this is you can write anything like a diagonal function, so that can be imported exported, because according to this file it is exported. This can be exported. Now I'll go to the main go.file file. So first in when I'm using this, when I wanted to call the functions which are declared in this geometry.go, first I have to import it. So, okay, so let's see what are the various ways we can import it. So importing local packages, let's say you have this geometry.go and now you have the various functions defined in the geometry.go. And now let's say that you wanted to import that geometry.go into your main.go file. So the first thing that we have to do is we have to import its name, the package name first. Okay, and the name of the package is this long. So we'll see how to create an alias for this name so that I can easily use it. So there are different ways. The first way is when you wanted to import a package, you import it here and then you create an alias name which is geometry. That means that using this name followed by dot, I can create I can call any sort of functions or the variables which are defined inside the geometry package. So it is the name of the package dot and the various functions. So now let's say, so this is how you do it. So first one is you create an import alias. So the thing is you create an import alias called geometry, and using that you can call it. And now let's say that you don't want to use this geometry key, so you wanted to directly use this area. So what you can do is you can use dot operator. So what generally this dot operator will do is it will bring the complete package into the current namespace of main.go. That means that it will going to completely import that this geometry package into the current namespace, so that any function or variable that is created inside that particular package can be directly referenced with this name. But the problem with this kind of dot imports is, let's say two different packages have the same area as the function, so it creates a confusion now, because this area might belong to one package, or at the same time it can also belong to the some other package. So it creates a lot of confusion, so it is not at all recommended to use dot imports. And now let's say you have imported a package. So you have imported a package, but you are yet to use that package. So once you are developing your source code, and once you import a package and you are not using it, so if you save this file, automatically this package is going to be automatically removed. But in order to not if you don't want to remove this, or if you don't want go to automatically remove this, so you have to use underscore. So what generally Go will do is Go will ignore this, and it will not be automatically removed to save this space. So this is called blank identifier. Similarly is the case for creating the variables. Let's say you have created a variable name which is of type string, and the name of the string is, let's say this is my name, but you haven't used this name anywhere. So this is an error in case of Go. But in order for you not to remove it, because you wanted to reuse it at a later stage, you just replace the name with the underscore. So now you will still have it in your program, but Go will not report it. So this is with the same import. So you've imported something and you are yet to use it, so simply use underscore. So this is about importing. So let us now go to the VS Code and see how to import our Go the geometry package which we have just created. So now in order to import the geometric package, what I'll do is, so I'll use double quote, and then this geometry package is inside this Go microservices module, and then slash the name of the package is geometry. And now I wanted to create an alias name. So the alias name, you can use geo or geometry or any other name. So if you save this is going to be removed, because we are not using any of the functions or the variables from the package that we have used. So what I'll do is I'm going to calculate the area by sending the length and width. So how will I do? So I'm going to create a variable known as area, and then I'm going to call this area function, so which is in the geometry package, but geometry package is being imported as geo. So it is geo dot area, and now I wanted to use a length and width as 1.2, so that they are going to so pass to the geometric package area function, and area will return the total area. So I'll be using fmt.println to print the area. So if you save this file, so it is going to, if you see here what it is saying, could not import Go microservices, no required module found. So the problem with this is we declared this Go microservices as the module, so which has this complete path. So what you have to do is you have to take this complete path over here, and you have to replace this Go microservices with that path. So now Go is not going to throw an error. So now the package import is also pretty much clear. So now area is also done. At the same time, you can also calculate the diagonal. I'm just saying it as diag. So from the geo module, so there is a function known as diagonal. So diagonal also needs length and width. So this is what. So we are going to print area and the tag. Okay, and now we are going to use go.run go run main.go to run this go file. So the what do you say, the area is 2 and the perimeter is 2.23. so this is about using the local modules. So these local modules can be used to group together a certain go files which does a similar work. Let's say that you have file processing, so you wanted to create a package for file processing, or you wanted have image processing logic, so you can create a package and put all the go files which belong to that package into that package itself. Now let us go to the final topic inside the Go basics, which is cross compilation. So Go can be used to compile, or we can generate the final executable not only for this operating system in which we are running Go, but also for the target operating system. Let's say many of us are using either Mac OS or Linux to create Go programs, but we wanted to run those Go programs or the final executables in the Windows platform. So in this case, if you try to compile the Go source code inside Linux, it is going to give you the Linux executable. But if you wanted to not to compile it again in the Windows, what you can do is you can use the cross compilation capabilities of Go to generate the executables that can target other operating systems. So if you wanted to get the list of operating systems that Go support, so you can use Go tool disk list. So this is going to just show you the different operating systems that Go is going to support. So it is Go tool list, it is disk list. So these are the various operating systems, like we have the Android, so we have the Darwin, FreeBSD, OpenBSD, NetBSD, and we have the Windows, Linux, so everything we have. So so this is about. So now how do you cross compile? So if you use go build main.go, so this is going to generate only main.exe file. I'm going to remove this test.exe. So it is going to just create the exe file which is specific to this Windows platform. But what if you wanted to target for the Linux? So you wanted to run this Go program or the Go application inside Linux. So we can use cross compilation capabilities by putting or by using some Go specific environment variables. So we have the Go OS. So I wanted to just put it as Linux. And Go architecture, so it can be your AMD architecture or Intel x86 architecture. So depending upon the architecture requirements, so you can cross compile. Let's say you wanted to cross compile for the Linux, but before that let me fetch all the Linux. So I wanted to compile it for the ARM64 architecture of Linux or Linux 386. So what I can do is, so it is Go OS as Linux and Go architecture as 386, and before that you have to use env as the key. And now if you run this, so it is not going to generate the main.exe, but it is going to generate a binary file that is supported for your Linux operating system. If you see, you have the main binary file over here. So easily now this can be copied into your Linux machine and it will run just like it is running in Windows. Now I'm going to run go clean, so that should remove all the executables in the current directory. So this is about various things that we can do in Go, which are basics. So now let us dive into the actual web development. For this I'm going to refer the official Go documentation itself. So I'm going to go to the Go official website, and then I'll just click on this get started, and then I'll click on this web dev. Okay, so I'm going to use this as a reference for all my web application needs. So about Go programming, so Go is an open source programming that we already know. So first example that we are going to see is the hello world. So let's see how to serve this using a simple HTTP server. So Go is battery included programming language. That means that many of the packages are already inbuilt. So we have a package known as net HTTPD. So that will have all the standard protocols for serving the HTTP request. So it can be either used as a HTTP client, or it can be used to set up a HTTP server. And then so Go already has some functions with some signatures. So the one such main signature that we have in the net HTTP package is, so this is the function, so which is going to take the request, and also it is going to give you the responses as well. So if you wanted to learn more about the packages, you can go to the official Go web page and click on the packages over here, and inside the packages you can search for various packages. So let's say you have the HTTP package, so this is the HTTP package. So from here you can see how to use the this Go program as a client, and at the same time you can also see how to set it up as a server. So here the server is listening on 8080, and you can also create various endpoints like latest /health/readiness. So we have various endpoints that can be created. So now what we'll do is from the official documentation only we are going to follow. So this is the function that is going to handle all the HTTP incoming connections. So in order to know what is this response writer, so this http.response writer is where you write your response. That means that whenever a request is coming on an endpoint, so what response that you wanted to send in the form of HTML. So remember, this is not as the JSON, this is an HTML response. And http.request, which contains all the information about your request, like the headers, the URL, the query parameters, so everything will be there. And in order to start to create a server, you can use http listen and serve, and the port on which you want your web server to listen on, and this is how you do it. So what I will do is I'm going to copy this entire source code, and then let us try to run it, and let's try to create a simple web server. So I'm going to open the main.go file only. So I'm going to comment out this complete thing, and then I'm going to start from scratch in the same file, main.go. So this is main.go. So what we have here is the package main, and then we have the two packages, fmt and net package, and then we have the main function. So here in the main function, so it is listening on 80 port. So we are going to create a HTTP server on port 80, and at the same time I can also use some print statements here using log. So I wanted to print something to the log, so I'll use log.println. So I'm just saying the web server has started, some information, and then this is log is a package. If you just save it, so that log package is also going to be imported. And if you see clearly, so we are creating various endpoints with the default signature for the HTTP. So here we are listening on /endpoint, and then on the response writer we are going to write hello, you have requested, and what you have requested, whether you have requested on a specific path like URL/health or URL/readiness or URL/API/v1. So what is that path? So this path can be passed using R, which will store your request information. So r.url.path, it is going to give you that path. So what we are generally doing here is we are printing a small HTML file where we are saying hello, you have requested this particular URL path. So I'm going to run this file, which is go run main.go. Yeah, so our Go server has started, so I can go to the browser. So I'm going to type the IP address of my machine, so which is 192.168.0.1110. Since this Go server is listening on 80, so no need to put 80. Okay, so let's say that you have also put some /health. So it is going to parse that this path for us, and it is going to be printed in the response writer. So let's say if you are using API/v1, so that is going to be printed here. So this is just for the demo. So now let's go to the official documentation again and see what else we can do for this. And now, so this is the first one, which is a hello world, And now let us go to the HTTP server part. Now here the same thing, but how to dynamic serve the dynamic request. So here the HTTP package contains all the utilities needed to accept the request and also to write the responses back. It can also process the dynamic request like the querying the path, or getting the parsing the query parameters or the URL parameters. So everything can be done over here. And at the same time you can also serve the static files like the static HTML files, etc. So now what I'm going to do is I'm going to parse a parameter or a URL query parameter called token. So what I'll do is I'm going to take this, so which is URL query. Inside the query I'm going to fetch a token, which is nothing but your query parameter. So I'm going to copy this, and let's see how can we use this. So I'm going to just put it here, but I have to use this value here. So what I'm doing is, so you have requested on this path and with token. So the token value is, let's say if it is a string, so I can use percentage this. Okay, now here with the token, so we are going to parse this token value. So now I'm going to save this, stop the server, and use go run main.go to start the server one more time. Now the server has started, so I can go to this. So this is the path API/v1, but the token value is not known. So the token path, the token value is a query parameter. So we have to use question mark over here, and the query parameter is nothing but your token. So the token value I'm going to give it as 222. So sorry, the typo here, token 222. So that is going to be passed. So that means that your dynamic request can also be passed using your net HTTP packages. So now let us see how to serve the static files. So the static files can be served from a directory known as HTTP static directory, and you have to create a file server, and you have to use the object name as fs. So this is just for the variable name. So what we'll do is we'll copy this entire source code. So instead of copying this source code, what we'll do is, since we already have this /endpoint created, so what I'm going to do is I'm going to create this file server, and I'm going to serve this file server on the /static endpoint. So I'm going to just use this, go to the source code, and then paste it here. So this is how and at the same time you also have to create a static folder. So inside the Go microservices I'm going to create a folder. I'm sorry, it is here, static. So inside the static I'm going to create a file known as index.html. so this will just do fine. So inside the index.html, so the first one is the doc type. So once you do the doc type, so automatically it should populate. Let's try with HTML. So it is not automatically populating. So inside the HTML, so we can have the head section. So inside the head section, let us just try to put some title. So the title I am putting it as DevOps made easy, some title, and then let us close this head tag. And now let us go to the body tag. I'm going to open the body. I'm just going to close it here, and then inside the body I'm going to just put one h2 tag. So I'm going to write a text known as DevOps made easy. I'm going to save this HTML file. So yes, everything is proper. Now let us go to the main.go file. Here we are serving the file server on /static location and at the same static endpoint. So I'm going to save this file, restart the web server. So we have the /endpoint and /static which is created newly. So once the server is starting, so I can just use /. So it is going to respond with the default slash result, and then if you do just static, it is going to give that HTML file. And one more thing that we have to note here is that, so you can also create this handler as a separate function. That means that for this complete the response for this handler, I can create a different function. Like let's say I wanted to create like a function known as a root handler, and then I should have this same method signature or the same function signature for the this particular handler as well. And for this handler, the response is going to be the same thing. So I'm going to cut this complete path, and then I'm going to put it here. But since I've removed it here, so what I'll do is, for this particular slash handle function, so the function that is giving that is serving this slash endpoint is this root handler. So I'm just going to put it here. So now this is also going to work in the same way. So in this way I can create various handlers for each API endpoint. So this is about using the various endpoints and creating various handlers. So let us go to the next example, which is routing using Gorilla Mux. So this Gorilla Mux, again, it is a package based on HTTP net HTTP, but this is much more advanced and it support wide variety of options apart from the options which are supported by the net package. So in order to use Gorilla Mux, first we have to import it, or we have to download that particular package from the GitHub. So we are going to see how to create it, and then for after importing it, we have to create a new router. So this new router it is going to handle all the incoming requests and pass it to the various handlers. Like if the request is coming on /health, it is going to send that request to that particular handler, which is nothing but your basic function call. And then it can also have various parse various URL parameters, like if the endpoint is books programming language page 10, so I can send I can parse this information and page number information from the URL parameters. So similarly in the earlier program, so the way how we registered the handler is using http.handle function, but in now we are using we are creating a new mux router which is named as R. So we are going to register using r.handle function. So I'm going to take this particular file over here. So now everything that what we have done, again, it is just to understand how to do the basic creation of basic REST APIs, but this time we are going to use the Gorilla Mux. So I'm going to just save this file, but the problem here is we don't have this particular package installed. So what we seen in the earlier scenario is, so in order to download as well as adding this into the go.mod file, so what we have to do is we have to use go.mod id command. So this will just download that package and then it will also update the go.mod. So if you see this go.mod file, so we have this Gorilla Mux automatically updated in the go.mod file. So now if you try to save this file, so you can see that the error is gone. So now if you see the main function, so here we are registering a new handler, and then what we are doing here is we are handling the function on this API call, which is books, title, page and page number. All these are placeholders, and then we are creating and then we are reusing this HTTP function. So this is the function signature, and then from the request that we are getting, so we are passing various the parameters or the URL parameters like the title, page, using this mux.where function call. So what we are going to do is we are going to print whatever is the title and page number that user enters from the URL, and then we are going to print it. So we are going to do the same thing, go run main.go. So I'm going to take this particular endpoint, go to the browser, and then after this IP address, since the port number is already 80, we don't have to give it, and then /books. So title, I wanted to give it as the name of the title, the book title is DevOps, and the page number that I wanted to put it as 10, which is the page number. So now you can see the output, which is you have requested the book DevOps on page 10. So this is about how to dynamically the parse your API request. So now we'll go to the next example. So at the same time, using Gorilla Mux, you can also restrict a particular handler to specific HTTP methods. Like for the, you can restrict this the API call only for receiving the post request, and some request for the only get request, some functions for the delete request. So you can use all these functions and methods of using the Gorilla Mux. So you can also explore the rest of the documentation for further information. So now what we are going to do is we are going to continue with our own custom example. So now we understood how to use Gorilla Mux to create our own handlers. So now what I'll do is, so I'm going to create various handlers. First I'll be creating a / handler and then health handler. I'm going to remove all this, and then I'm going to create a new function known as health handler, that going to import the method signature, which is from the net package, and here health. So in case of health, I wanted to just print a JSON response instead of sending the HTML response. The JSON response which I wanted to do is status is equal to up. So whenever I call this function, I also wanted to print some information in the terminal. So I'm going to use log.println. So I'm just writing checking just application health, and then I wanted to return a JSON value which is status is equal to up. So basically this is nothing but a map. So if it is a map, I can also create a map using response as the name of the map, and then I use shorthand notation to create a map. So the map the key is of string, and the value is also a type of string, because status is equal to up. So both of them are a simple strings. So status is equal to up. So this is just a map, but this is not a JSON which I wanted to return. So you have to use comma over here. But if you go to the documentation, so there is also one more documentation for the JSON. So this JSON, using this JSON package, we can encode and decode, but in our case we are going to use encode our data. So explore the rest of the documentation. So I wanted to take this particular command and I'm going to paste it here. So here we are encoding the response, which is the W, but what we are going to encode, we are going to encode this response variable. So now this is going to also import JSON here automatically. So now this is just serving, but here we are not using health handler anywhere. So for this I'm going to create a new /health endpoint, and the handler which I wanted to use here is health handler. So this is how I define a health handler and remove the rest of the things. And at the same time, when you're serving, so you can also use log.fatal, so which is going to log any fatal errors whenever you're trying to run your server. So let me go back. So it is log.fatal. So it is automatically going to, sorry, it is a small log, that's the issue. Okay, so we have defined the health handler, but at the same time I also want to print the current date and time. So what I can do is I can go to the official packages for the Go, and then I can search for a package known as time. So I'm going to click this package, and in order to get the time, you should use time.now from the time package. So I'm going to use t which is a shorthand notation. So I'm going to add one more key value pair, which is known as timestamp, and then I wanted to use this time.now. So this time.now is the package from the time, and then you put comma at the end, but this time is undeclared. So if you just save, this time package will also be imported. But if you hover your mouse, you can see that you cannot use time.now because it is a type of type time, but it is not a string. Because here if you see, the map we have declared as key as string and value as string, but here value is not of string type, it is a time data type. So I can also use dot string, so to convert that into a string. So now let us say save and try to run this particular file. So this time, so we should have the health endpoint ready. So I'm going to just use /health, that is going to give me health. So the status is help and the timestamp. So if you keep refreshing this page, you're going to get a different timestamp. So that is about creating a health endpoint for time. So we still have to create two more routes. So I want to get the details of the particular, let's say, Kubernetes pod or container, like the container host name or the container IP address. So we are going to create them now. At the same time, I also wanted to create a root handler. So that means that r dot handle function. So we will create for slash with the something known as root handler. So I'm going to create a new function. I'm just going to copy this and paste it over here. So I'm going to name it as root handler, and then for the root handler I'm going to do a different thing. So whenever someone create calls slash, so I wanted to send the HTTP response as success status code. So for this I wanted to write some information to through the writer. So it is write dot. If you see, we have various options, so we can also write to a header. So what we wanted to write, so we wanted to write HTTP status as OK. So you can also use HTTP status as page not found or a gateway error. So all these errors are here. So let's say we have a bad gateway or bad request. So accordingly it will also send the proper status code. Let's say if it is status OK, it is going to send the 200 as the response code. And at the same time I'm going to print some log information when someone hits this endpoint. So it is just like serving the home page. And at the same time I also wanted to write some information to the home page, which is an HTML information. So I can use formatted print, and I wanted to use W, and I can just type application is up and running. So I wanted to run some HTML response. So now if you just save, so we have also created the slash endpoint. So I'm going to restart the server, and then so instead of /health, even if you enter slash, so now it is going to so is application is up and running. But if you go to inspect, click on network and refresh this page, so you're going to see the status as 200. So what if you wanted to give a different status code? So instead of status OK, I wanted to create a status known as bad request. So just save this file, reload this server, and now once you refresh this page, now you can see that it is 400, which is a bad request. So I'm going to revert it back to the HTTP status OK. So now so far so good, we have created two handlers. I wanted to create a third handler known as get details, or probably /details should also work fine. So I'm going to get the details of the IP and the host name of the container. So I'm going to create a new one called details handler. So again I'm going to copy this particular function, so name it as the details handler, and I'm going to log this fetching the details. but right now I don't have any information yet. I'm going to remove both these lines. But for fetching all these the details, I'm going to create a separate package. So I'm going to create a package known as probably details, and inside details I can create details.go. so this is a package called details, and then here I wanted to create various functions. So first function is, let's say, like get host name. Okay, so for getting the host name, so let's ignore for the all these for now. So first thing is we have to get the host name. So how to get the host name? So we have various packages for the OS module. So I'm going to go to the official packages and go to OS package, and then if you search inside this OS package, we have something known as host name. So this is how you to get the host name. So if you call this host name function, so it is going to return a string and an error object. So I'm just going to copy this method signature. Let's just copy it here just for time being, and then let's comment it out. So now I'm going to create a custom function get host name. So I don't have any input parameters, but output I'm going to send a string and the error. So how to get the the host name? So the host name shorthand notation. So inside the OS we have a method known as host name. So this is what we have identified from the documentation. So once you call this host name, what generally it will do, it is going to send both error and the actual host name from the official documentation. So the name as well as the error object. That means, so we have to capture both host name as well as the error, or you can capture them using err. If you don't want to use that variable, just use underscore to nullify it, or it is something like using the blank identifier. So now we have the host name. So what I have to do is, if someone calls this get host name function from this details package, they have to have this host name returned. So I'm just going to use return host name, and then if you want, you can also I can also capture error here, and then you can return the error. So this is my first function. So get host name. So I'll go to the main. So here what I'll do is I'll get the host name from a package which is known as details package. So what I have to do here, so I have to use import the details package. So I'll go to my copy this the name of the module, and then I'll import the details package like this. So now I wanted to import it with the alias which is details. So now from the details package, so I have a get host name function. So this is going to return both host name and error. That means that you should also capture ER. So this is something like a tuple unpacking in case of Python. So now what I have to do is I have to check error. So if the error is not nil, that means if there is an error, so I can panic. It is like creating an exception and terminating the program. So for panic, I'm just sending the response of the error. So if the error is not if the error is nil, if there is no error, so temporarily, in order to ignore this error, I'm just using println to print that host name. So now what I'll do is I'll just restart the server and then go to the slash details, but this time it is not being it won't be printed because we are not writing any to the response writer. But if you open the terminal, so you are going to get the host name which is digital twin. So now I'm going to stop the server. So the next thing which I wanted to implement is function to get IP, and I really don't know how to get the IP. So I found a package known as a net package. So in the same net HTTP, so we have a function package known as net. So inside net, so we have something known as ADDR, I think, yeah, this the initial thing, which is Dale. So here if you see this package and just type for dial, so here you can send the UDP request to any particular DNS like the Google DNS server and then fetch the information. So I had some hard time understanding, so not understanding, just writing and parsing the code for the IP address. So what I did is I made a simple the Google search for get IP using Go. So there is a Stack Overflow blog, so where I found the information. So I'm going to leave the link in the description as well. And this is the one that worked for me. So using net module and inside net package and the Dale function call and sending the UDP request to the 8.8.8, so we are going to get the information about all the local addresses. So I'm just going to copy this entire source code from the Stack Overflow. So I know this is not the best practice, but just for the demo, I'm just taking the references from the Stack Overflow, and then I'm just going to create a function call. So here we are importing the net package and sending the UDP request. So if you do not have the outgoing connections blocked, so consider using any other package to get the local IP address of your container or pod. So if the error is not null, you will log the error. And then what is this differ is, before your function or the control exits from this function, it is going to run one more function called connection close. So here we are connecting, and then before your control leaves your function, you are going to defer that connection call. And then local address, so this is the local address that we are going to return. But if you hover your mouse and see, let's just save this file once, and then if you hover your mouse, it is saying no result values expected, because you're not returning something here. So let's say if I just put string as the return type, just to know what is the exact return type. So it is saying cannot use this local local address IP, so which is of type net IP, as a string return value, because this type is net IP. That means that I have to return this net IP, because that is the actual type, which is not a string type. So now we also have the get IP, and if you want, you can also return error just like before. So you can also return the error object like this, and you can put the return types inside the brackets. Sorry, it is error, so you can also use error here. So now what I'll go to the main function, and in the details what I'll also do, I'll also get the IP, and in the same details dot get IP. But here along with the IP, it is also giving me the error. So if you don't want to use error, you can use underscore to completely eliminate it. So now I will use this IP to print. So if I just save this and reload this server, and just get the details, so it is going to print in the terminal. So this is the host name, and this is the particular IP address. So now I wanted to serve this as a JSON response, so I'm going to copy the same logic which I've used here, like the response. So I'm going to just copy it here, and then this response is map string and string. So this time this one becomes the host name, and this becomes the actual replacement for the host name variable here, and this becomes the IP, and the actual value is IP. So I'm just going to replace it. But the problem is we are using the map value type as string, but this is not string because this is of type net IP. So similarly I can also use string function call to completely change it. So now I'm going to serve this as the JSON response, which is completely a RESTful type of application. So now if I just click on details. So now as you see, this is a complete JSON response. So we have the host name and the IP address. So we are almost done. So we have created 3 endpoints, health, slash and details, and we have completely tested our application. So now what I wanted to do is I wanted to locally build it using go build main.go. So this is going to just generate the exe file inside my local file system. So in order to run it, you can use /main.exe. so this is going to directly start this server. So let's see if we have printed. Yeah, so the reason why it is not showing anything is we haven't included any the log print statement, but yeah, it works. So this is the slash, and this is the what we have the details, and we have the health endpoint. And now what we'll do is we'll go back, we'll also see. So log.println, so we can use server as started. Now if you try to build it again, and now if you run it, so you're going to see that server has started. Okay, so now everything is done. So let us now try to create a Docker file for this complete application. So before creating the Docker file, so I wanted to also create the Docker ignore file, because this geometry and static are not the ones which I'm going to use. So what I'll do is I'll just create a file which is basically inside your microservices folder only, like the one is docker ignore, and the ignore file which I wanted to ignore is, so I'm going to ignore all the geometric folder and then static files folder, because I don't want to send them as build context, and any sort of exe files which are there in my current folder. So these are the things which I wanted to use as docker ignore. So now let us also try to create a Docker file. So we'll be creating two types of Docker files, one for the local testing and one for the production, which is multi-stage builds. So now what we'll do is we'll start from the from. So the from will be using Golang. So at the same time, let us also try to start the Minikube cluster. So I'm going to see if Minikube is up and running by using Minikube status. Yeah, so it is up and running. Otherwise you have to use Minikube start. And at the same time, I also wanted to configure the my Docker CLI to use the Docker engine running inside the Minikube. So using Minikube Docker env. So this we have already discussed in our earlier classes. So if I just use docker ps, it is going to get all the containers information inside my Minikube cluster. So from Golang, so I'm going to use the latest as the tag, and I wanted to name it as builder stage, just in case of multi-stage builds, but you can leave it for now. And then from is done. So I wanted to set some working directory as well, which is /app. And now first I wanted to download all the dependencies. That means that, so first I wanted to copy the first one is the go.mod, and at the same time go.sum inside the current directory, which is /app, because we have set the working directory as /app, and then we use run go.mod download to download all the dependencies that we have mentioned. So if you remember, inside the go.mod we have the Gorilla Mux as the dependency, so that we are doing we are downloading everything. Then let's copy the rest of the source code using copy, and then we can use run and then go build, and output I wanted to save it as a main. and dot to find the go file, main go file in the current working directory. I'm naming it as main for the final output or the executable. So at the same time we should also use expose command to expose 80. So that's for the documentation. And coming to the entry point, which will run your final executable, which is your main. So /main, so that is your final executable. So now what we'll do is we'll try to build it. So using docker build -t. So I wanted to use go app normal because this is a full build. I'm going to use docker I wanted to tag it as go app normal. So the tag is let's stick with the latest and dot. Sorry, so space is needed. So now the go container, the container image is built and tagged with this name. So what I'll do is first I'll run it using docker run -d. The port mapping is 8080, 80 on the host and 80 on the container, and the name I wanted to use as the web, and the image is go app normal, and latest is the tag. So now it has started a container. If you do docker logs -f and the name of the container is web, so it has started listening. So what we have to do is first you have to fetch the IP of the minikube and 128. So I'm going to see the logs at the same time. So take the minikube IP address, then go to the IP address of the minikube and hit enter. So this is your app is running, and then /health. So it will give you the health endpoint, and then details. So basically it is going to give you the host name of your container and the IP address of your container. So this is how you build it. But the only problem, so first let us remove the container using docker rm -f and web. And now if you do the docker image ls, so the image size for this go app normal is more than 948. So this is way too long for a simple application. So now what we'll do is we'll use multistage builds, so to further reduce the size of the image. So for this, either you can use Alpine to run an executable, but I'll use go distoless image from Google to do it. Google distoless image. So these are language focused images with just enough number of utilities and security best practices to use for your docker. So this is about the quick example for Golang application. But the first stage we already done. So let's talk about the second stage. So what we'll do is we'll take this as the from image. So I'll go back to my VS Code. So in the second stage I'm going to take this. So do not want to put the entry point and expose here, because in the first stage I'm just building the main as the final executable, which even this image can also run. So the first stage I'm going to name it as builder stage, as builder, and then using copy command and -- from stage from is equal to builder, and the location inside the builder is /app/main. This is the final executable, and I wanted to use dot to copy into the current stage. And now you can use expose here in this stage, which is 80, and at the same time I wanted to run it using the cmd and /main. So this is how you. So in the first stage we are creating the executable main. In the second stage we are copying from the first stage, and then we are just executing the final artifact. So I'm going to use go build, same thing, but this time I wanted to use go app. So for multistage I'm just tagging it as go app ms. So it is going to build the image and then it is going to tag. But if you do docker image ls for this image, so you can see that go app ms is just 26 MB right from 948 MB. So that is a significant reduction in the image size. So now you can also run the same image, run the image in the same way. Docker run -d image. So instead of normal, it is ms now. And at the same time, you can see the docker logs. So it is docker logs. Okay, let us type it. So it is docker logs -f web. So the server has started. So if you keep refreshing this page, so you are going to get the same information. So the container ID probably would have changed. Okay, so going forward, we are going to use the same multistage image, created image. I'm going to remove the container. So now what I will do is I will directly run create the docker compose file for this particular application. So I'm going to create a file known as docker-compose.yaml. so you can also take the reference from the web to get the so let us take the web version. So docker compose. So I'm just going to get the template. I'm going to just copy this template, write it here. So we don't have the volumes, so we don't have any links and volumes. So this is the base one. So version is 3.9 services web. So if you want to build that service, you can build it. At the same time, you can also put the context, the location where your docker file is existing. So the context is dot, remove the build from here. So in the present working directory only, you will going to file the docker file. So if your docker file is named with the same name like capital D docker file, so you don't have to put this particular statement itself. So now once your docker image is built, what you wanted to name it as. So I wanted to name it as go app ms latest, go -app latest. And then coming to the port section, it is 8080. And then I also wanted to use a statement known as restart always to restart the container every time it fails. And it is up to you to put a custom network, and the name of the network I wanted to use as web network, but you also have to create it first. So networks in the next line, you're going to create the web network. So this is how you write a docker compose file. And you can also use docker compose -f to build. So what we are going to do is we are going to use docker compose build to build this particular docker image. So it is built and tagged, and then you can use docker compose up -d to run this particular container. So networking is created, and it will put that container inside that particular network. So you can also use docker compose ps to get the containers in that particular the services mentioned in the docker compose. So it is running. So you can also verify it by running this particular health check endpoint and the details endpoint here. So now we are going to use docker compose down to bring down the complete stack. So now I'm going to create one more folder for all my Kubernetes related objects. So inside the Kubernetes, I should have a deployment file. So it is deployment.yaml file, and I should also have a file known as service.yaml file. So I'm going to take the web reference again, and so deployment in Kubernetes. So I'm going to take the template of Kubernetes deployment, just copy it and paste it here. And this is a deployment. So this is a web deployment. label as, let's say, web, and then 3 replicas. So I would like to go for 1 because I am running low on system resources. Okay, so let's say 3, no problem. And labels I wanted to use as a web. Here also container labels as web, and the container name I wanted to use as something like go web app something, and the image is go app ms latest. And so let me verify whether it is the image name. Yeah, it is go app ms latest. So I'm going to also put the image pull policy because sometimes image pull policy is creating an issue. So I'm going to just image pull policy as if not present. Yeah, so almost, and container is running on 80. Yeah, so this is done. So let us go to the service file. Okay, unfortunately we mentioned everything in service. Let me cut and paste it in the deployment. And for the service, again I'm going to check the service in Kubernetes. I'm going to create a node port service for this. Yes, so this is not the node port. Yeah, so this is the node port service. Let's say it is a web service, node port, app and container porter. So the selector is app is equal to web because inside the deployment it is app web. So here the selector is also the same thing. Type is node port. Port, if you want to hard code, you can hard code. So else let us remove this hard coding value. So let us save this. So deployment and services are done. And now what I'll do is I'll use kubectl utility, kubectl apply -f. So I'm going to apply that Kubernetes complete folders, so it will deploy the deployment and service as well. So I'll use kubectl get po and svc. So it will give me the so I think there are already some previous deployments running. So I'm going to kubectl delete deploy -all. So it is going to delete all the deployments. So now I'm going to apply it one more time. Get po and svc. So all the containers are in the creation state, all are running. So now I can take the IP address of my minikube cluster. So it is minikube IP, it should be the same, and then port number is 30678. So I'm going to get this port information colon 30768 slash, so let's say it is details, so it is running. So you can also get the slash health, it is also running. So for slash it is going to respond. So now everything is working fine. So I'm going to get kubectl delete -f, and at the same time if you want to see the load balancing, so how the load balancing options actually work, because there are 3 instances. So basically, so the details should be responding with 3 different values. So for this what I'll do is, so I'll create a new pod. So kubectl run -it. So I wanted to name it as curl pod -rm. So to remove it whenever I exit the pod. Image I wanted to use as curl images /curl, or instead, in fact, Nginx Alpine has the curl inbuilt. So now I'm creating a pod called curl pod, which is running Nginx. So now what I'll do is I'll curl the internal service, which is web service. So if I just do curl internal service, which is running on 80, and now if you search for the details, so now I'm getting the details from one pod. So this is the details from another pod. So if you see, I'm getting the different responses from different pods. So this is how the load balancing is working. So I'm going to delete everything from that Kubernetes folder. Now quickly what I'll do is I'm going to create a Helm chart for this. So for the Helm chart, I'm going to create a template using Helm create go app. So if you see here, one more folder is created, which is a go app, which is a Helm chart. So we don't have any charts, we'll delete it. Inside the template, we don't want tests, HPA, ingress, service account, we don't need. So coming to the values, so values, it is up to you to define how many number of replicas you need, and the image is go app ms, and the tag is your latest tag. Replicas, let's say 2. So that's it. So a type of service is node port. So that's it. So we don't need any changes here. And then coming to the deployment, so for the deployment we have the labels taken from the helpers. Selectors are also done. Metadata, annotations, labels, image pull secrets we don't have, service account we don't have, security context we don't have. Okay, so we can ignore image pull secret, service account and service context we can remove. Container security context is also not needed. Image pull policy secrets are also not needed, by the way, only image pull policy is needed. Ports, container port is 80, readiness, liveness, all these node filters are not needed. So this is the basic deployment file. And now coming to the service object, port is service port, which is 80. So target port is also 80. I'm going to replace this, and rest all are same. So now in order to test this Helm chart using a Helm template, and then I can template name. So this is the rendering of the template. So I can use Helm install, name of the release as go-app, or let's say web as the release name, and the folder where the Helm charts are there is go app. So now it is deployed. So if I just do kubectl get pod and svc, so there will be 2 replicas and 1 service object created. So 31579 is the port on which your application is listening. So it is running on a now port, so we can have the details, and then we can also have the health information set. So that's it. So we almost done. So the one thing which we wanted to do is we wanted to push all these to our GitHub repository. So for this I wanted to create a .gitignore file. Okay, I think .gitignore is also not needed. Okay, let us ignore all the exe files that are present, because we don't want to. And before that, so what we have to do is we have to use git init to initialize it as a repository. And now we also have the git ignore, which is ignoring the exe file. Otherwise you can also delete this. And then so I have to add the remote. So git remote add origin. So we have already created the GitHub repository for this. So we can take this command git remote add. So we can use git status and then git add -a to add it to the staging, git commit, init, and then use git push origin master. So this is how you push your changes to the GitHub repository. So inside the Go microservice, so we have the master branch where you will have everything. Go.mod, it will define your Go dependencies. Go.sum, the cryptographic hashes for your the complete dependencies. We have the Docker file, Kubernetes, Helm chart, and we have the various packages like details.go etc defined and pushed.
That's it for this video, guys. If you like our video, consider subscribing to our YouTube channel and joining our Facebook group. The links are given in the description below. You can also scan the QR codes being displayed in this video. And for any training requirements, you can join our Telegram channel where we post regular updates on our upcoming trainings. You can also WhatsApp us on the number being shown here. You can also drop us an email for any kind of training inquiries. Thank you.